Free body diagrams. It might sound funny to others and they will say it's easy, but trust me, it's not. So to draw a free body diagram, actually a free body diagram is something like this. It's something like this. These arrows represent forces and their directions, and this dot is the object on which those forces are acting upon. So first of all, I'm gonna use this image as an example. Let's say we have a book that is placed on a table. Okay. To draw a free body diagram, step one, you need to find yourself a dot. This dot represents the book, and the first thing you need to do always is to draw this force right here. It has to be directly facing downwards, like towards the center of the earth, which is directly downwards. And this is the force of weight, is the weight of the book, because this book has a mass, and every object that has a mass on earth has some sort of weight. And secondly, you need to check if your object is resting on a surface or not. And on our case, this book is resting on our table, so naturally there is a normal force right there acting on the book, which is supporting the book. So the second force right here will be the normal force. And that's pretty much what drawing free body diagrams is. You only need a dot to represent your object and arrows to represent your force, and they must be facing in the directions of the net force. Remember, the normal force has to make an angle of 90 degrees with the surface of rest. Okay, let's get another example. Let's say we have a tree. Let's assume that this is a tree. Okay, this is a tree, and okay, this is our tree. This is our tree. This is our tree, and then there is a rope right there, and a ball is hanging on that rope. Now, if they say draw a free body diagram of this ball, first of all you need to get the ball itself, like this dot will represent the ball, and automatically you need to draw the force that will represent the weight, or mostly known as Fg, the force of gravity. And you can now ask yourself, is this ball resting on a surface? And the answer is no. So there is no normal force because it's just hanging there. It's suspended on a, let's say this is a rope, on a rope. But this rope is preventing this ball from falling down, so it's supporting the ball in some way. So there is a force facing upwards. The rope is kind of pulling the ball upwards. So this is the tensile force acting on the ball, and that's the free body diagram of the ball. And another trick I need to teach you is that when they ask you to draw free body diagrams, just check at the end of the question, just check for a figure like this. This will represent the marks you're gonna be awarded for that free body diagram you are going to draw. So each mark from this represent a force. So let's say if they asked you to draw a free body diagram of this ball, the marks will be 2. So it's a mark for this force and a mark for that one. Let's look at more example, like more complex ones. Let's look at more examples. Let's say we have a rough surface right here, and we have a crate with a mass of 10 kg, and we have Johannes, our friend from the last lesson. So it's pushing onto this box with a force of, let's say, 20 newtons to the right. And they say draw a free body diagram of this box. Automatically you know how many forces you have to draw in order to be awarded full marks. Okay, so to draw this free body diagram, you're going to need a dot to represent the crate. There we go. And the first force to draw is the weight. You see, this is the weight of this box. And then, is it on a surface? Yes, it is. So there is a supporting force called the normal force. And you say, are there any other forces acting on this thing? And there is. Johannes is pushing it to the right with a force of 20 newtons. And because this is a rough surface, there is a frictional force. So this is the force applied by Johannes. And because this is a rough surface, there is a friction force that kind of oppose the motion of the crate. Let's say the crate is moving that way, the frictional force will be moving that way. So this is the frictional force, the kinetic friction, and that's pretty much the free body diagram of this crate. Now let's look at another example. This one will be a bit more complex. Let's say you are on an inclined rough surface, okay, and you have got yourself a crate right there. Excuse my throwing. And they say draw a free body diagram of that crate. Let's say this angle is 30 degrees. Okay, and first of all you need to draw a dot to represent your crate. And the first thing to do is to draw a vertical force that is facing directly downwards. It's the weight. It will always be facing directly downwards. Let me draw this line right here, which will represent a plane. Like it's just the slope, the representation of the slope. You need not to draw this on your free body diagrams. Let's say this is our slope. Okay, and the second thing to check is to ask yourself, is this resting on a surface? And yes, it is resting on the slope. So there is a normal force. You need to draw the normal force right there, which is it makes a 90 degrees angle with the plane, you see. And because this is a rough surface, if this thing is moving downwards, there has to be a frictional force that is opposing the motion. And that's pretty much it. You also need to label your forces to be awarded full marks. So yeah, I think this is helpful and you will get better at drawing free body diagrams. Peace.